My interest in physics is maybe a little difficult to trace because I came from a family where neither of my parents went to college. So I had no guidance. I also didn't go to schools where I had a particular mentor. I was, good in math and things like that, so I was maybe inclined in that direction, but I didn't know really any of that. I think my real interest, if I traced it back, was curiosity about the physical world, which is what physics is. And the first identification I could make was when through my curiosity, I asked my father a question he couldn't answer. The first one. And the first one was why, I don't know how old I was, maybe 10 at the oldest, maybe younger, was why does ice, which is made of water, float on water? And my father couldn't answer it. And before that, I think probably any question I asked, that one sticks in my mind because of the fact that he couldn't answer it. And it took me a while, but I scurried around and learned about what ice was and learned that it expands a little bit when you freeze it. And therefore it's lighter than water. I mean, I understood why a cork floated or why a coin would drop to the bottom, but this one confused me. So for the first time, I asked a question that somebody couldn't answer, and I learned kind of how to answer it by going and looking and answering it. I never got to the point where I asked, in retrospect now, I did the next question, which makes you a real scientist at the time. So I wasn't. I only had the budding maybe curiosity, and that is that I should have asked once we said water expands, which somehow I believe that answered the question, put it aside. But why it expands is maybe a more interesting question, and that my father certainly couldn't answer, and I couldn't understand at the age of 10. But I think the progression of being a physicist is to ask those kind of questions, answer it, understand that there's a next level of the same kind of question, and answer that. Then I was interested. I made a ham radio and things like that as a kid, but I didn't really know what physics was. I went to school in Berkeley, but I started as an engineering major. It was kind of the closest I could come to something that had my talents, and knowing that I had to make a living. I came from a family that didn't have a lot of resources, and I knew engineers had an occupation. So I started in engineering, absolutely hated it from the very first. I had to take a course in engineering drawing, and they didn't like my arrowheads. And I had to take a course in, these were the two that I remember, in surveying, where you went around the campus in Berkeley and used this instrument, which was fun for about 10 minutes to measure the heights of buildings. And then as a shy kid, I was embarrassed to be on this campus looking through this thing while other students walked by and pointed. But I took freshman physics, and it had a lot of problems to solve. I always liked solving problems, and somehow out of a combination of hatred for what I was studying, engineering, a dislike that I won't go into for chemistry, which I also was studying, and so I drifted into physics. Once I was in physics, then it was a love affair, so I've done it ever since. Well, I think nobody personally. I went to a big school, Berkeley, and there were famous people, but that I didn't. I even worked for Owen Chamberlain, who won a Nobel Prize years ago for the anti-proton, but I didn't know him very well. He was a distant advisor. So nobody personally. I think the person I most admired and probably went in the direction of physics that I went into, which is particle physics or nuclear physics, was Enrico Fermi. And I followed his life and how he had come to the U.S. and his work on the bomb, of course, but his approach toward nuclear physics, the fact that he integrated both the practical part, the experimental part, where you measured things and built things and understood the underlying physics. And that was kind of my ideal, not to break it up into some people who do calculations and some people who do science. So I do experiments. So as a kind of intellectual person or somebody I admired, it was Enrico Fermi. I never, unfortunately, had a personal mentor that guided me. So I just kind of drifted where I am. Mentoring can be really important. I think an interesting thing is, they call you on October 3rd and blah, blah, blah. And I got a zillion emails after that. And looking at the emails, there's a whole bunch that came from various ex-students or postdocs that I had years ago and have drifted in different places, or a student that I don't remember or barely remember who told me how, and that's probably why I stick with me, how I said something to them or mentored them and it made a big difference. In my case, I didn't happen to have a mentor and I drifted in a direction that fit me very well. But I think a mentor can be really important in guiding you past what you can do yourself. So mentoring, I think, is very important. I didn't personally experience it. I apparently have helped mentor people, which I almost have learned about as I've come to this prize. I have a whole series of emails, not just one, how they had this, maybe they've glorified it with history, I don't know. But I had one from a student who did poorly, and I kept encouraging him as a freshman, and now he's a physics professor somewhere, so I had faith in him. That's not exactly mentoring, but somebody showing faith. And then other ones that I guided them in some direction. I was kind of unaware of it, because you do it as your job, and nobody gives you feedback later, so you're not aware of it. Well, first, in California, you hear at 3 in the morning, so it's a little unusual at 3 in the morning. In this case, it wasn't like an absolute 100% surprise. We knew we were candidates, maybe not this year or next year or whatever, because it's rather soon, but we did something that people have responded to. So I wasn't totally surprised in that sense, but there's nothing like getting the real phone call, even though you're blurry-eyed in the middle of the night. I did fall asleep. I did awaken. I woke up to watch it on streaming because I hadn't gotten a phone call. And so I thought, well, not this year, or not me. And then almost as soon as I got out of bed, my cell phone, of all things, started ringing, and that was the call. At the end of the phone call, he asked me how I felt, and I answered it spontaneously, bleary-eyed, middle of the night, and in the same way I'll answer to you, because I think it was as good as I could say, even after kind of reflecting for now a month, and that is that I felt both, I couldn't give a single word, but I felt both humbled and thrilled at the same moment. So a mixed combination of these funny. My colleagues, I think I have a lot of colleagues because we work on a very big project. I think they're really, truly excited and take it as a success and recognition of what we all did together. And I think of it that way, that it's a recognition of that. And so we have lots of them arriving in Stockholm, almost 100 for a dinner that we're throwing, and we're thrilled that they're going to be here. So I think, if I take it away from myself, I think it's fantastically good for science. Science gets too little recognition compared to all the awful things that happen every day that we read about, or things that are not very interesting or profound, considering how much impact science and scientific developments have eventually on our lives and how important it is. It gets very little impact because of the tradition and prestige of the Nobel Prize. It brings scientific developments, whether it's a circadian rhythm or our work on gravitational waves, or just science itself, to the public in a way that goes all around the world. Almost, not totally unique, but I think we need more of that in science, and that comes along with the Nobel Prize. Yeah, I think I grew up. I worked most of my life in particle physics on large accelerators where we have large groups, and it's built into the system. We built our own group here, and I think the difference is that there was no such field. And so most of the, maybe not some of the younger ones now because it's old enough, but most of the, at least the fundamental group that made it a big collaboration, joined for particular reasons rather than grew up in something. And so they joined because they happened to be an expert on lasers, which we use, but were looking for doing something that was really important with lasers, or control systems that we use and wanted to work on something where it was really challenging, or they're know physics from general relativity from Einstein, but would like to actually test it in a real way. So the people that have come to it both bring relevant expertise, more than usual large collaborations that we have, and maybe a real desire and choice that they went into a certain field rather than grew up in that field. So in particle physics, it's now mature enough. We've had generations of accelerators that it's a great field, but it's not like ours in the sense that this is a pioneering effort. It has an incredible variety of talents and people, but they're all there because they brought something to the, not all of them, but most of them because they brought something special to the problem. Absolutely essential. I think not just collaboration, but collaboration on a scale that's beyond, people have always collaborated. I could work with you or somebody down the hall. So collaborations at a small scale have existed for a long, long time. But on a bigger scale, I don't necessarily mean 1,000 like we have, but let's say bigger than a few, so that you have to have some sort of organization. It's absolutely essential, and it's where the opportunity is. So if we just look at the Nobel Prize in Physics since the new millennium, the three that stand out to me are the discovery of the fact that neutrinos have mass and oscillate, that we have found the Higgs particle, which represents where mass comes from in nature, and we found, after 100 years, gravitational waves. All three of those involve very large collaborations and very large technical efforts. I mean, there's theoretical Nobel Prizes too, but I'm picking on the experimental ones, which all required modern technology and big teams. And it's a combination of those two. What's available to us today and the opportunity for the future is the fact that technology is changing so incredibly fast. We all have this iPhone, which has more power in it than anything I could dream when I was a young student, and from getting us around to solving, mathematics on it or communicating or blah, blah, blah. So technology has changed so fast. As I grew up, we had developed, as an experimental physicist, technology as we needed it, a very slow process. Now, if I was young, technology is changing so fast, the question is to grab the technologies as they develop, because now you have the opportunity, and apply them to some of the biggest questions we have in nature. And I think for a young scientist, it's a fantastic time. As we see, I gave you 3 examples. That's in the past. We have more possibility in the future just because of the technology that's developing. Well, bringing together a large group of scientists, whether it's 10 or 100 or 1,000, if you just bring them together, I think it's complicated and probably then has to be shaken out in that some of the wrong people are there. Our particular collaboration grew. So when we formed it in 1997, there were less than 100. That sounds big to people, but compared to 1,000, we're more than 10 times bigger. It's grown steadily during that time through students, through other people joining. The hard part isn't somehow for us then getting the right people together, because we did by attracting people, the right people together, but how you organize such a large group of people to go down the same path. And you can imagine, if I pick something hard, I'll give you a hard problem. We wrote the discovery paper on gravitational waves. How does a group of 1,000 people decide which adjective to use when you write the paper? Do we call it a discovery? Do we call it an observation? One has a very different feel than the other one. And how do you decide with 1,000 people? We did manage to do that, which is a success, and nobody complained, of having a process inside and enough people, enough ability to voice opinions and so forth. I will say that there's a subgroup inside of this which has done all the technical part. So the technical part, which is, to me, the biggest accomplishment that we can measure something so small, is really Caltech and MIT. So we're the ones funded by the National Science Foundation. We're 1/10 the size of the collaboration. The collaboration is big to do all science, but this fantastic instrument was really built by Caltech and MIT. I think government funding of science and technology is maybe country dependent, so I can really only answer for my own country. In my country, if it's not done that way, the development of, let's say, technology, for example, is done for economic reasons, not for any reasons that have to do with understanding or intellectual or even a long-range view of what a country needs. So I think whether it's fundamental science or developing future abilities that a society needs, a government has to play a role. We can't do it completely outside of a government. If we talk about my country, where there's a lot that's done, there's always been a lot of developmental work and discoveries and so forth done inside of industry as well as inside academia. But I think that has, because it's profit-oriented, has an orientation that forgets about kind of the bigger picture, so we have to do it intellectually. If we also combine it with teaching and mentoring, it needs to be done in a university, and you don't want to get universities too mixed up with profit making. So I think it's essential for those two reasons. I think what's opened up my eyes through the gravitational waves is how little we really know about the universe, that we can't really go back to the earliest. I was mostly a physicist, understanding the physical laws, physical nature, and what's added for me intellectually is understanding more about astronomy, cosmology, and so forth. But we've understood a tremendous amount in the last decades, but it's just beginning. And I think that much will happen from the future of my own field, which we've just opened up. But I'll forget that for a minute because I think that's great. I talk about it in another way. But it's clear to me that that even though we've had 400 years since Galileo of astronomy, that there's new instruments coming on that are going to make an enormous impact. So if I had to join something right now, and it wasn't what I'm doing, and I was young enough, it would probably be what's called LSST. It's the large survey instrument that's being built to do a whole survey of the sky that it sees. I think it's 3 times a day, and watch for anything that changes. And I think it'll be ready. It's being built now, and it'll be ready in the early 2020s. And of the instruments that I know about, projects that I know about that are real and not just dreams, we all have dreams, that one I think is going to have a huge impact in an area that I'm sure we're just kind of learning about. So transient events that we look at, which is something different today than yesterday, are pretty much the most exciting, for me anyway, in astronomy or astrophysics. And now we'll have a kind of a systematic way of looking at it. And so if I were a young person now, I'd be tempted to join LSST. Oh, absolutely. Since I bungled my way into science, not knowing what my background, what could lead to what, and in the absence of assuming that everybody can be mentored and taught along the way and follow their own guidance, for people like myself to pay back, in a sense, by speaking to young people, not just teaching ones who have come to Caltech or something, I think is really a very important, not just for myself. It's important because I learn and see young people, and that's fun. But I think for young people to be stimulated by seeing an older person who can talk on their level and try to stimulate them is absolutely essential. So we have to improve our educational system and kind of how we incorporate science and how we get young people, especially women, minorities, why everyone who wins a Nobel Prize is a bald old white man like myself means we're not taking advantage of all that we have. And so what can be done and the only way to solve that is to treat people when they're young in ways that stimulate them to go into science. Have dreams and pursue them. I think that's the best advice you can have. It takes hard work, but and you can't always reach your dreams. And we worked for 20 years on something that we might not have reached our dreams. Would I have been sorry? No, because it was fun all the way. Pursuing something where you really have objectives, even if you don't get there, has all kinds of satisfaction along the way. There's a quality you shouldn't have to be a successful scientist, I think, and that is that many people have a need which I would call for instant gratification. And I think if you're so oriented around instant gratification, you can't really do the kind of work that's required, which takes patience and dedication to do real science. I think the best advice to give to a young person is to find out what you like the most, find out also what you're good at, and find out how you can teach yourself, not just be taught. And if you learn how to teach yourself by whether it's going to libraries, whether it's working something out and learning how to do something by doing it, but basically the combination of learning how to learn from others, learning how to do things yourself, and having some goals is what I would like. I kind of bungled through that. I always had that in the background, but it really wasn't that I understood where I was going. And somehow I managed through some tortured path to get there. But I think for a young person, self-awareness is a very good virtue. If you're not aware of yourself, what you like, what you're good at, what you'd like to do, and keep that in your mind as you try to do things, you're just much better off if you can do that. I like reading. As a kid, I mentioned earlier that I didn't really know what it was to be a scientist. I didn't have that guidance. I think if I had any goal at all when I was 10 years old, at the age when I asked my father why an ice cube floats on water, it was to be a fiction writer, to write stories. And I think that was true until maybe I was in high school. I always loved storytelling and loved fiction and read prolifically and liked to write. So all the combinations were there. And in my next life, that's what I would do, is try to write fiction. I probably wouldn't be as good at it as I'd like to be, but that's where I was as a kid. Yeah, I actually think, this is non-substantiated, that of the many colleagues I've had in my life, that many of the ones who are the best, I can't define best, but we know what best is, love maybe fiction and storytelling, and most scientists, I'd say a minority, read much fiction. So I think the idea of creativity, storytelling, imagination are maybe secondary, but a very important element in not just plodding ahead with talent. Well, the whole pageantry, part of what's always good, is to experience something you never experienced before. Of course, getting the prize itself is fantastic, but I think everybody's reacting in different ways to all the events, and I'll use the word pageantry, and having to wear dark suits, which I never wear, and having to wear tails and all this kind of stuff. I think that's very secondary. For me, keeping the tradition of a certain kind of experience, forgetting about getting the actual medal itself, and going through all that and witnessing it is what I look forward to. To me, it's like something I would never see and do otherwise, and here I get to be in the middle of it. So that part's fantastic. Some of it makes me nervous, like how do I tie a white bow tie, and can I actually bow right and so forth, but that's okay. It's worth it. Yeah, so one thing that pleases me a lot is that it's just not the three of us that are here. We are using some of our prize money to bring so we invited a whole set of LIGO scientists, almost all of them accepted gladly and are coming. We're having a big banquet for them one of the nights, I forget the 9th, and that heartens me because it's really essential in the way the Nobel Prize is given that individuals be picked out, but this, in our case especially, is really a team effort, and the team, the leaders of the team get to identify in this way, and we're very heartened that they don't just look and say, why those three and why not me, and so forth, and there's very little of that. And as I say, it's not responding just to me or Kip or Ray Weiss, but we're symbols of kind of the whole effort, and it's the recognition of what we've all done and taken such hard work and long paths to get there.